Okay, so hi, my name is Aina Alia, the leader for this experiment, and together with my group members, which is from group 1, would like to present for the experiment 5, which is the measurement of jet forces. So next, I will pass to my group members.
Hi, my name is Xin and I will present the report of summary. Experiment 5 is an experiment about measurement of jet forces to investigate the reaction forces produced by the change in momentum of a free flow when a jet of water spreads a flat plate or a hemispherical surface and to compare between experimental and theoretical forces which are exerted by the jet. The effect of different deflectors can be seen at a constant flow rate by changing the type of deflector and putting the desired weight on the lever mechanism. In this experiment, experimental theoretical forces and the percentage of relative error for both the flat plate and hemispherical surface can be determined. Next, I will present the theory of the experiment. A jet of fluid when impinging upon a flat plate or a hemispherical surface generates a force due to the change of momentum of the fluid according to Newton's second law of motion. For example, when a velocity of water v from jet nozzle with diameter d straight on a flat plate or a hemispherical surface, the rate of change of momentum produced and its momentum is the same with the force F exerted on the surface of the flat plate or hemispherical to support the water jet. The F generated by a jet of water when it stretches depends on the shape of the surface, which is flat plate or a hemispherical surface. Figure 1 and Figure 2 depict a jet of fluid issued from a nozzle of diameter d, moving vertically outward with velocity v1 and stretch a flat plate and hemispherical surface respectively. The jet is deflected by the surface of flat plate or hemispherical to an angle theta and leave the surface with velocity v2. Figure 1 shows jet of fluid scratch a flat plate and Figure 2 shows jet of fluid scratch a hemispherical surface. Next, the theoretical force generated when the jet of fluid scratches a flat plate is F equal to rho AV1 square minus rho AV2 square cos theta. Theta is 90 degrees, thus V2 cos theta cos 90 degree is 0 and V1 is 0. The equation can be written as F equal to rho AV1 square. For the hemispherical surface, the theoretical force generated is F equals rho AV1 square minus rho AV2 square cos theta, and theta is 180 degree. Then the V2 cos 180 degree equals negative V1, thus V2 equals negative V1, and this equation can be written as F equal to 2 rho AB1 squared, where F represents theoretical force exerted on the flat plate of hemispherical surface. Unit is Newton. A represents cross-sectional area of nozzle. Unit is meter squared. Rho represents density of water, and unit is kilogram per meter cube. Theta is angle of water flow after impact on the flat plate of hemispherical surface, and unit is degree. V1 and V2 represent velocity of water jet before and after impact on the flat plate or hemispherical surface respectively, and unit is meter per second. Next, I pass to the next presenter.
Hi, my name is Adrian. I'm going to present about the procedures. The first step is assemble the tested deflector. Step 2, set the pointer to 0 by adjusting the screw at lever mechanism. When doing this, we do not place any weight on the lever mechanism. Step 3, turn on the main switch and the pump. Step 4, slowly open the flow control valve and put the desired weight, for instance 1 Newton, on the lever mechanism. Adjust the flow control valve until the pointer at lever mechanism is at 0 notch. Step 5, close the sliding valve and determine the flow rate of water by recording the time required to fill up 3 liters volume of water in volumetric measuring tank. Step 6. Open the sliding valve and repeat step 4 and step 5 by increasing the desired weight on the lever mechanism until the flow control valve is at maximum opening. Step 7. Turn off the main switch and the pump. Open the sliding valve and close the flow control valve. Step 8. Remove the weight on the lever mechanism and change the deflector, a flat plate to hemispherical surface. And we repeat step 2 to step 7. Next, I'll pass to the next presenter to discuss about the data analysis.
Okay, hello. I'm Jordan. I will carry on for the data analysis part. As usual, we are required to record some things and calculate some things. For this time, in the table, there's measured force, which is F mean recorded in Newton, volume of water collected in liter, time in second, actual flow rate in liter per second, velocity meter per second, and theoretical force Newton. Next is percentage relative error, which is calculated by the mean minus the theoretical over theoretical times 100. This is for data. This is the data for flat plate, and this is for the hemispherical surface. Now I pass on for the discussion part one.
Okay, so back to me, Aina Ella, and I will present the discussion part together with Ahmad Yudin. So first, next, we need to plot a graph of log F measured versus log V for both the flat plate and hemispherical surfaces on the same graph. So here is the graph, which is the blue line represents the flat plate, while the orange line represents for the hemispherical surface. And for this graph, we obtain the equation for both lines, which y equals to 1.7034x minus 0.9068 for flat plate, and y equals to 1.8399x minus 0.6849 for hemispherical surface. Next. So based on the graph, we need to estimate the slope of the graph for both the flat plate and hemispherical surface and compare with the theoretical value as shown in equation 2 and equation 4 respectively. Comment on the difference. So there are two equations, which is equation 2 and equation 4. So here, which is F theoretical equals to rho AV square for flat plate and F theoretical equals to 2 rho AV square for hemispherical surface. So after we log for both sides of the equation, we can obtain that log F theoretical equals to 2 log V plus log rho A for flat plate, and log F theoretical equals to 2 log V plus log 2 rho A for hemispherical surface. So both of the equations obtained from flat plate and hemispherical surface, they are similar to y equals to mx plus c. Thus, we can calculate the slope for each line, which equals to m equals to y2 minus y1 divided by x2 minus x1. Next. Therefore, the gradient or slope for flat plate is equals to 1.7034 for flat plate and 1.8399 for hemispherical surface. From the slope obtained, we can clearly see that the slope of this hemispherical surface is steeper than the slope of the flat plate. The differences may be due to the angle of the water hitting both surfaces. These will also affect the theoretical value. Next. So B, we need to estimate the y-intercept ratio of hemispherical surface to flat plate and compare with the theoretical ratio. As deduced from equation 2 and equation 4, comment on the difference. So based on the equations from the graph and also using equation 2 and equation 4, we can get y-intercept and calculate the theoretical y-intercept for both flat plate and hemispherical surface, which y-intercept ratio is equals to 0.7553 and the theoretical ratio is equals to 0.67. So From the value obtained, the theoretical value ratio value is different from the y-intercept ratio value, as there are minor and major losses that need to be considered when the fluid is flowing in the pipe and hits the surface. Next, for last one, for part C, which is we need to compare the force exerted on the hemispherical surface with the one on the flat plate. Which one is greater and why? So, based on the results and data analysis of this experiment, we could conclude that the force exerted on the hemispherical surface is higher than the flat plate. This is due to the momentum produced by the hemispherical surface is slightly higher than the flat plate. And since the angle for the flat plate is equals to 90 degree and cos 90 degree is equals to 0, so that is why the equation for flat plate is equals to F theoretical equals to AV square. While for the hemispherical surface, the angle is equals to 180 degrees, so cos 180 degree is equals to -1, and that makes the equation for hemispherical surface to F theoretical equals to 2AV square. Therefore, the force exerted on the hemispherical surface is greater, as we can clearly see that the force exerted on the hemispherical surface is twice the force exerted on the flat plate. Next, the second part of the discussion, we were asked to compare the percentage of relative error for both the flat plate and hemispherical surface as a function of jet velocity. Comment on the analysis and explain your reason. So from the data analysis obtained, the percentage of relative error for flat plate is ranging from 0% to 33.3%. While for the hemispherical surface, the percentage of relative error is ranging from 0% to 23.1%. High percentage of relative error obtained may be due to several errors that occurred during the experiment. This is because the errors will certainly affect the result recorded, such as the condition of surfaces for both flat plate and hemispherical plate will lead to inaccurate velocity. Next part, I will pass to Ahmad Yaudin.
I will continue on for the second part of the discussion. Briefly discuss factors contributing to errors or inaccuracy in experimental data and the possible recommendations to improve the existing results. Factors contributing to errors or inaccuracy in experimental data are as follows. First up, human error due to inaccuracy when taking down the time in seconds. Next is the control valve being not fully open can cause the reading to be slightly off. And last, mistakes in initial calculations resulting in more mistakes in later calculations. For recommendations, we have ensure the control valve is fully open before adding the weights. And next, if possible, repeat the experiment for 3 times and measure the average to get a more consistent data. And next is make sure there is no zero error when reading the watch. Now I pass on for the oh no no wait. Suggest 2 applications of jet impact in industry. First of all, to generate electricity. Impact of jet is used to rotate the turbine, namely Pelton wheel in a generator. And next is water jet cutter, capable to slice metal or other material by using high pressure and high velocity of water jet together with abrasive substances. Now I pass on for the last part.
In conclusion, a jet of fluid generates a force when impinging upon a flat plate or hemispherical surface due to the change of momentum of the fluid according to the Newton's second law of motion. On the graph of log measured force versus log V for both the flat plate and hemispherical surface, we can clearly see that the slope of the hemispherical surface is steeper than the slope of the flat plate. This causes the angle of water hitting the surface of hemispherical surface increases as compared to the flat surfaces. There are differences between the y-intercept ratio and the theoretical ratio as there is presence of major losses and minor losses. Last but not least, the percentage of relative error for both the flat plate and hemispherical surface will affect the function of jet velocity. That's all from our group. Thank you.